Hello, I'm going to just cover a couple topics right now. I want to look at some more data structures, especially heterogeneous. Well, miscellaneous and heterogeneous data structures. Okay, so what I want to do is take a fast look at factors and another look at matrices and their attributes and such. Factors are going to cause us a little trouble when we look at the main ones I'm going to discuss, which are lists and data frames, which is a type of list. Okay, let's try this out. First of all, this is just in keeping with the last talk, factor. Factor is interesting. A factor is a type of vector that's stored in an unusual way. The idea of factors are therefore data sets that are, well, where you want to signal to the function that you're using a categorical variable, that you're treating as a categorical variable. So in some sense, when you have a categorical variable, it's nominal, so it doesn't really matter what you call the levels. And it's going to emphasize that in the structure of the factor. So let's make one of those. So factor, put some data in. Okay. If you just do this, it's very unusual when you take a look at what you get. So we have 1, 2, 3, 4, 5 unique levels. Levels 1 through 5. If we look at them, there they are. They're strings. They're considered nominal. Okay, so there's values 1 through 3, 4, 5. And look what happens when you look at the structure. Oh, let's look at X itself. Okay, X comes back and shows us our original data set and tells us what levels we have. But the structure is unusual. I'll make one that breaks it a little better than this, or shows a little better. So it recognizes that it's class factor. Notice. Okay. It has 5 levels. Those are the unique values. But the vector that it really is, so this is an attribute. Levels are an attribute. So notice it's a factor, has a class set to factor, and has levels 1 through 5. Those are attributes. What it really is then is a vector with attributes. It's an integer vector. See? And what those integers are is, instead of actually saving your original data, what it does is it tells which of your levels to use each time. Now this is a little bit flaky, but so this is saying, okay, use the first, whatever these level names are, we'll use the first of them, that's our first data point. Second of them is our second data point. Third is the third data point. The fourth one's fourth data point. Fifth one's the fifth data point. Or fifth level, and then the last one's the fourth level again, which is a 4. Actually, 1, 2, 3, 4. That's not too illustrative because I typed 1, 2, 3, 4 for those. Let me do one that's a little more obvious. Factor. See, let's put. You've got a 1, you've got a 30, you've got a 50, you've got a 65, you've got a 50, and a 50. Okay. Now let's think about what's going to happen with this. What it's going to do is create a factor, and it has unique levels 1, 30, 50, and 65. Now let's put another one, 70 and 50. So the unique ones are 1, 30, 50, 65, and 70. So we can see that. So let's look at the structure. Okay, it shows us that we have these levels, 1, 30, 50, and so on. And it says our first data point is from the first level. Yep, it's a 1. Our second value is from the second level. It's a 30. Third one is from the third value. That's a 50. This one's the fourth value, which turns out to be a 65. Then this one's the third level again, which is a 50. So notice it stores it doesn't store the actual value. It stores a vector that tells us which of the levels shows up at each spot in our original data. So levels X, there we go. By the way, an interesting thing happens here. If we try to append more data to this factor, we're going to have trouble, because if we try to append data that's not one of these 5 levels, well, these 5 levels have been stored in as attributes. So we'll kind of mess things up by extending this vector. If we add to this vector without changing the levels, we could be in trouble. So what you have to do is, with factor, if you anticipate there's going to be some additional categories but that don't show up in your original set, so we have this data. What if we think, okay, there might be something other than 50, 65, 70. Let's say there's a possibility in the future of adding data that has the value 100. So we might want to add that to the set of levels. Okay. And there you go. Let's look at the structure. Again, there's 6 levels, but it doesn't indicate that they're anywhere in our data so far. Okay. So that's all a factor is. A factor is a vector. And that's all there is to it. So, and I want to take another peek at matrices, since we were talking about matrices before. It turns out matrices, again, are a vector, and they're a really fundamental addition to a vector, because normally when you want to create a new data type, well, you have to set the class attribute. But it turns out just adding the attributes that is the dimension to a vector is enough to make it into a matrix or array. So functions in R are smart enough to know that when there's a dimension attached, the class is automatically going to be a matrix. So let's look at if we just stuck in some numbers. Okay, obviously that's just going to be a numeric. Okay, but here's the trick. I'm going to use attribute to actually attach. I'll attach some data. I mean, not some data. I'll attach dimensions to this. So I'll say, okay, the vector y is going to get the attribute called dimension. And in that dimension, I'll make 2, 3 dimension. Now let's look at the structure of y. Notice, now it recognizes that it's a matrix. And when we do the class y, it's a matrix. And we've attached the attributes dimension to it. That's one attribute that's often attached. We saw that you could change class. Another one that's often changed is names. So names is a common attribute. What that does, it allows us to give a name to each value in the matrix. So now there's also row names and column names that work for matrices too. The obvious way we can name the rows and columns. But let's say okay, so it has a set of names now, and I wonder. So in general, it doesn't really, in the way it prints out matrices, it's not going to show the names here, but you can attach names to almost any sort of things like vectors and data frames and so on. So we'll see how that works with something like a vector. Let's do another one. That's just a straight vector. 1, 2, 3, 4, 5, 6. You'll notice with a vector, it actually, when you print it out, actually attaches the name to each one of the values. So that's just another attribute. Let's look back at the matrix there. Okay, it has the dimension attribute, and we've also put names on there. Names can even be used to access items from other objects, so we'll see that later. So let's get beyond the vectors and get to heterogeneous things. Well, I'll try to keep this a little bit shorter. I guess that's too late, isn't it? So, so we're going to look at lists and data frames. So all a list is, it's almost like a vector. It's a series of boxes that you put things in, except you can put a different thing inside each box when it's a list. You can even put lists inside lists. Because of that, it's the way to build complicated data structures in R. And if you look at almost every function that outputs a data structure, they use a list to do it. So let's just see how a list works really fast. And I should mention, there's three ways to set names to things, because a lot of times you want to name each variable or each part of something like a list. One way is just like up here using the names. You say names and then your object and then attach a list of names. Not a list. Vector of names. Second thing, there's even a command called setNames, okay, where you can put the object and then follow with a vector of names, but I'm not going to use that one quite yet. And the last way is when you create the list, you can put names in, and I'll show how that works. So let's go V. Let's say we have a list, and the first thing in our list is one of our matrices. Let's put the matrix Y as the first thing. Okay. And then we'll put a vector for the next thing. They don't have to be the same length. They don't have to be the same type. We'll put a string here, yo. And we'll put the value infinity. Okay, why not? It doesn't care. So when we look at this, this is what it is. It has this double bracket means it's the spots, there's 4 spots in this list. One contains the object Y. Next one contains the vector 1, 2, 3, yo goes here, and the infinite value goes here. Okay. And something that's kind of funny, there's 2 ways to access things from a list. If you do double bracket, let's go 2, what it gives you is what's actually inside that second part. So it's going to give you the vector. So look when we say class of that thing, it actually gives a vector back. On the other hand, if I do just V of 2, it's going to give me the same thing, but instead of removing the thing from the second spot, the vector from the second spot, it actually will break out this whole thing as a list with just one thing in it. So let's look at V2. Notice it has this thing right up front telling, now it's a list with just one thing. I essentially broke my list into pieces and took the second spot here and made it into its own list when I do V2. So this is when you want to pull the actual object out, which in this case is a vector. This is when you want to leave it as a list of just one item, one vector. So look at the class here. Guess what? It's a list. Okay, so what was our object we just created? Class V is a list. Okay. Shouldn't have any attributes at this point. Nope, no attribute set. Has a length. Has 4 spots in it. And in fact, you can make a list of lists. So be a little careful here. When you put a list inside of a list, it depends on which command you use. So let's do new V. If we use concatenate, what's going to happen? So we take our old list here, and then we put something else in it, like a new string. Okay. What combined is going to do, it's going to say, uh-oh, there's a list in here. So it's going to be a combined lists. And what it's going to do is create a new list with just one more thing in it. It's not going to make a list of 2 parts. Okay? This isn't going to be a list of 2 parts. It's going to be a single list that consists of what was in this list with one more item. So let's see what new V looks like. Okay. Notice we have the same 4 things. It's just a straight out list of 5 types with the new string as the 5th one. So how do I put a list inside a list? Because all this does is leaves just one list, but adds things to it if I do concatenate. Well, let's go newer v. It's if you use the list command. So if I do list v and new string, it's actually going to make a list of two objects. The first object is itself a list, and the second one is new string. Let's look at what's in there. See? Newer v. It says, okay, here's a first spot, and after it comes the entire list v that's been shoved in the first spot of it, and the second spot just has the label new string. So if you want, you have to use the list command if you want to put lists inside of lists. If you want to name things, you could do this. You just put the name equals. So v equals v. That's just going to make sure that my first item, that first list v, is called v. And the second one, I'll call it st for string, is going to be new string. So I name things. So this time when I create the list, I've named the two parts. Okay? Now this says, okay, it's part v, which contains that first list v, and then here's the part st, which contains that new string. And that's how I can extract them, by using that dollar operator. So it's really a function, but so v is, there's the list from the first part, and st is, oh, sorry, v $st, that's going to be the second part. So dollar sign, rather than doing the equivalent, which is taking the second spot, now that I've named that spot, I can extract what's in it with that dollar sign operator. Let's look at the structures of these. Structures are actually nice and clean. So this says list of 4. That's the first thing in here. Has names attached to it. It's a matrix. Here's your vector. Here's a character string, and here's an infinite numeric. Okay, real number. Let's look at a nested one. Oh no, I don't think the new v was nested. Hold on, let's see. No, it wasn't. It was just with a fifth thing added. So you see, here's the 5 parts. They don't have names. Let's look at the structure of newer v. Now this one's nested. Notice it says here's v. The outer part is a list of 4 things. Newer v is a list of 2 things. The first one is v. The second one is st. And then it shows what's inside of v right there. And notice it's given them a name, because I set names for these. Up here, these are the been through the desert with a object with no name. There's a song in there somewhere. But down here, these, because I named these, you'll see that those names showed up. All right, quite enough on that. I'll talk about a specific type of list. So, oh, one last thing though. I mentioned that almost all functions put out lists as when they create objects. Let's look at one. It's the linear regression, lm command. And if we look at that, for instance, return. Let's look at what it does inside that function. It's a nice long function, isn't it? Here we go. Lots of R code. Head down there. Here is where we make the output. So the lm command outputs an object, z, and notice it's a list. So they name the coefficients, they put in the coefficients, they put in residuals, they put in fitted values, they put in weights. In other words, they're attaching all sorts of different types of output from this program in one single large list. Okay, and what do? They set some attributes to those parts of the list. Yes, that one gets an attribute, that one gets an attribute, and so on. And then finally, as the very last part of the function, by just putting z there, what that does is it guarantees that that list will be the output of lm. So when you save the output of lm, you're really saving that list. So the idea is if there's lots of things you want to output from a function, you bundle them together into an object. And you pretty much always use a list to do so. Okay, so I'm going to look really fast at one last one, which is data frame. A data frame is a special kind of list. It's a list that's supposed to look like a data set. So what's the key characteristic of a data set? Well, every single column in a data set is the same length. So that's really what a data frame is. And you can easily name the columns, which correspond to data, and the rows, which correspond to observations. So let's see how that works. Let's see if we had a few data values. So we got XX. We had a YY. That consists of, oops. Ooh, it's going to do something strange, though. We'll see in a second. This is going to be quasi-amusing. Or maybe not. 1, 2, 3, 4, 5, 6. Okay, that has 6 things in it. So we have a logical, see, there we go. Okay, that seems like enough. And what you do is you just put those all into data frame. So you use the command data frame. The nicest way is to name them right away. So I'll call this one var1, XX. Why not? I can call it anything I want, but I'll call them var1, var2 equals YY, and var3 equals ZZ. And when it creates a data frame, something interesting is going to happen. Notice the nice thing, as opposed to a matrix, is that each column is if there's coercion going on, it's only going to be within a column. So variable 1, which I can get at by saying, what did I call it? var1 is going to be, I think it's doubles, but we'll find out in a second. Oh yeah, there it is. The only funny one is the second one. Notice we put in names, so we would think that would be a vector of strings, right? Because if we had just done that just straight out, take a look at that, we would get a character vector. But actually, when we look at what happens when it's put in a data frame, the data frames do coerce. If there's anything that is a character, it will coerce that whole column into being, it figures, hey, this is data. If you're putting data with characters in it, it ought to be categorical, so it's going to convert it to a factor. Okay. So let's look at var2, type of new dat $var2. Oh, wow, integer. Why is that? Oh, remember, a factor is just an integer. It's not strings, it's an integer because it's an integer vector, because fundamentally it's a factor. Yep, so is factor, it is a factor right there. So I think I can even look at that as a structure. So if I look at new dat, the second thing, var2, notice it's a factor. So be careful, there's a way, the book talks about this too. There's a way to stop it from doing that. But generally the philosophy is if you're putting anything with strings in as a column in a data set, it should be a categorical variable. If it really is names for each observation, you should use the row names command and actually make the row names correspond to the names. So you can override this, though, as I said. Let's look at the last one. Type of new dat $var3. Okay, logical. Yep. The class itself of new dat is a data frame, and let's look at its structure. Again, looks a lot like a list, doesn't it? Other than, it has a class data frame attached to it. So it says data frame, 6 observations of 3 variables. But notice this part looks just like your general sort of list with names var1, var2, and var3, which I could set to anything I wanted. This is a numeric vector. This one's a factor. This one's a logical vector. Is there anything else I want to say about this? It turns out you can put really strange things inside of a data frame. Oh, let me set the row names really fast though. Row names of new dat. Oh, why don't I just set these same row names as I put the names here? As odd as that will be. So now let's see what we get when we do new dat. So I've actually, instead of having that as a categorical variable, which is kind of silly for names, I can really put those as the observation labels. That's really what I should have done. Okay, one last thing I will try with that. Oh, I should look at the attributes. I've set several now. Names, which are the column names. I have row names attached, and there's a class data frame to the fundamental type, which is a list. Okay. So again, just like matrices were made out of vectors, data frames are made out of lists with a little bit of checking and conversion of types. Anything else with a data frame? Yeah, there's one thing we want to be very careful about doing with data frames is sometimes people coerce them into being matrices, even temporarily, and then turn them back to data frames. Can you guess what horrendous thing will happen if I try to coerce a data frame into a matrix? I'll call it UG. As matrix should do the coercion. The problem with matrices is, the trouble with a matrix, it's not a list, it's a vector, so it's going to use coercion and everything's going to be converted to the same type. Oh, everything's a character now. So that's really not what we want to do. Yeah, and now if I try to go back and make it numeric, I'll get NAs in that column. Let's see. Ugh. So if I desperately try to return, I'll get nothing but trouble. So be careful about conversion into. There's been several mistakes even in R packages where attempting to do conversions where you change it even temporarily to a matrix cause it to lose types or coerce the types. And I think that may be it. Yeah, I think so. I will stop here. That's enough. I guess we'll be talking about subsetting in class.